Start on an introduction to functions. All right, so just starting on some terminology. So let's say, for example, you have y equals 7x plus 2. Okay, so this just shows the relation between the x and y values. Okay, so if you plug in x equals 0, you get a y value of 2. You plug in x equals 1, you get a y value of 9. You plug in x equals 2, you get a y value of 16, and it keeps on going. So that's kind of their relation. If you plug in one value, you get another value. Okay. Okay, so the actual definition of the relation is the set of ordered pairs okay, and your ordered pairs is just some x comma y. So before, when I said when you plug in x equals 0, you get a y of 2, that ordered pair would be 0, 2, which is just when x equals 0, y equals 2. Same thing if you plug in x equals 1. You get a y value of 9. When x equals 1, bless you, y equals 9. And so on and so on, and it keeps on going. Okay, any questions on that so far? All right. The domain is the set of all possible x values. And the range is a set of all possible y values. Okay, so if we were to set that up, let's say, for example, what if we wanted to determine the domain and the range for, let's say, for problem A? You have 2, 3, 2, 4, 0, -1, and 3, -1. And let's say for B, you have -3. Let me clean that up a little bit, give it a little more room. We have -3, 1, -2, 1, 0, 1, 1, 1, and 2, 1. Clean that up. Okay. So remember, your domain is just all possible x values. So for A, in your x spot, you have 2, 2, 0, and 3. Okay, so your domain is just 2, 0, and 3. Yeah. Alright, my bracket's a little fast and they get a little messy. So you have 2, 0, 3. Or you can put it as 0, 2, 3 if you want to put it in order, but it doesn't really have to be in order. Okay, and your range, remember, that's all possible y values. So you have 3, 4, -1, and -1. So you have -1, 3, 4. And we'll just put that in order just because. Okay, so remember this, all possible x values. And this is all possible y values. All right, so any questions on that so far? All right, okay, so let's try for B. Okay, so your domain, if you notice all your x values, -3, -2, 0, 1, and 2. So you have -3, -2, 0, 1, and 2. And your range, if you notice, they're all just 1s. If they repeat, you don't have to write them over again. If you have 5 1s, you just have to write 1 one time. So your range is just 1. All right, make a little side note. No need to write more than once if they repeat. Okay, so even though 1 appears over and over and over and over and over, you don't have to write 1 one time. All right, so any questions on that one? All right. Yes.
So how did you get the range 3 and 4?
The range 3 and 4 for A, for this one. For that one, all of your y values, these are all your y values. Here, 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 and there. So all you have to do is list all the y values that appear, because it's always going to be in the form x comma y. So you have all your x and all your y values. So once you just list them all there, that's your range. Okay. Okay. Any other questions on this one? All right. Okay, so let's say, for example, instead of just a common set of ordered pairs, we have, let's say, find the domain and range for and let's say if these are cities, and let's say for this one, this is the population in thousands. Okay, so let's say if you have Lubbock, so if you have Colorado Springs, oops, should have given myself a little more room. And clearing that up a little bit. So if you have Omaha and Sacramento. Okay, so let's say if you have here 370,000. Let's say if you have here, if you have 197,000. So if you have 404,000. Say if you have 445,000 and 206,000. Okay, and let's say here lines up with there. Say Colorado Springs lines up there. Let's say Omaha lines up here, and let's say Sacramento lines up there. Okay, so this is your input, and this is your output. Move that down a little bit. Okay, so whenever you see input and output, your input is just a fancy way to say X values. And your output is just a fancy way to say Y values. Okay. So that means your domain, all possible X values, which is Lubbock, Colorado Springs, Omaha, and Sacramento. Okay, and your range all possible Y values. And that doesn't mean every Y value that you have over there, just the ones that are actually used. Okay, because remember, if you wanted to put this as an ordered pair, you would have Lubbock, comma, 206. You would have Colorado Springs, comma, 370. So if you wanted to put those as an ordered pair, you'd only list the ones that were actually matched up with an X value. So your range here is going to be 300. Uh-oh. Didn't need that comma. 370, 404, 445, and 206. Okay. So again, it's just a way of saying your X, comma, Y. All right. So any questions on that so far? Yes.
So you just disregard the 197 because none of the X values correlate to it?
Exactly.
Okay.
Yeah. Now, if you had an X value that went to the 197, then you'd use it. Yeah. All right. Any other questions on this one? Okay. Oh, I'll leave that up. Make sure everyone's done. Excuse me. All right. Move that over there. Oh, let me set my- here we go. All right, so now we're going to get into the definition of a function. Okay, so a function is just a relation to where every X value has only one Y value. Every first component of an ordered pair like I said, just X value corresponds to exactly 1 y value, well, second component. Or y value. Okay, so that's the technical definition of it. All this means is that every x value has exactly one y value. Okay, that's what all of that basically means. Straighten that up some. Okay, so let's say, for example, if you wanted to determine if the relation is a function. And let's say for problem A, we have the set of -2, 5, 2, 7, -3, 5, and the ordered pair 9, 9. And let's say for problem B, we have -3, 2, 0, -2, 0, 3, 1, 5, and if we had 6, 6. All right, so let's start with A. Okay, so is A a function or not a function?
Nope.
Yep, actually A is a function. And all you have to do is look at all of your x values. Because if you look at x equals -2, you don't have -2, x equals -2 for any other y value. You look at x equals 2, you don't have x equals 2 anywhere else. You have x equals -3, you don't have -3 anywhere else. You look at x equals 9, you don't have 9 listed anywhere else for x. Okay, so actually A is a function. So A is a function. Uh-oh. I already have A written down. A function since every x value has one, or only one, y value. Okay, so remember, it's just going to be written as x comma y. Okay, so we try the same thing with B. Okay, so is B a function?
No.
Nope. Why not?
Because it has two zeros in it.
Exactly, because 0 has more than one y value. Okay, so you know it's not a function. Since, x equals 0 has two y values. Okay, so you have 0, 2, or 0, -2, and 0, 3. So you can't have x equals 0, y equals -2, and also have x equals 0 and y equals 3. Okay, so as soon as x equals 0 pops up with more than one y value, you automatically know it's not a function. All right, any questions? Yes?
So well, it only matters if the x's are duplicates? Because like the first one in A, there's 2 5s in the y, so it doesn't matter?
Yep, the y's don't matter at all. So if you had all different x values and each and every y value was a 5, it would still be a function. It was kind of one-sided that it only applies to the x's. All right. Any other questions? All right. Okay, but anyone else still writing? Looks like everyone's done. All right, so let's say, for example, let's say determine if the relation is a function. And let's say for A, we have 1, 1, 2, 2, negative 3, and 0, 0. Okay. For B, you have 11, 6, and the ordered pair negative 1, negative 2, and the ordered pair 0, 0, and 0, negative 2. And let's say for C, you have negative 4, 8, negative 2, 5, negative 1, 8, and 1, 4. Okay, so what about A? Is that a function?
Yeah.
Yep, it's a function because every x value, 1 only has one y value, 2 only has one y value. Same with negative 3, same with 0. So it is a function since every x has only one y value. Or you can say x value. That value looks a little messy. There we go. Okay. What about B?
No.
Nope, not a function. Okay, because x equals 0 has two different y values. Okay. What about C?
Yeah.
Yep, it's a function. Same reason as A. Every x has exactly one y value. All right. Any questions on that one? Okay. Everyone's still writing. Looks like everyone's done. Okay, what if we want to determine if the following are functions? Say for A, you have A, B, C, D, and E, and this is your input. And for your output, you have red, blue, green, orange, and yellow. Okay, let's say these line up here. And Now let's say for B, okay, so for your input, you have 1, 2, 3, 4. And for your output, you have A, B, C, and D. Let's say if all of these, this goes here, this goes here, this goes here, this goes here. Okay, so is A a function?
Yeah.
Yep, actually it is. Because remember, your input is kind of just a fancy way to say your x values. Okay, so each x value has one arrow coming out of it. So that means each x value has only one y value. Okay, so for A, it is a function. Since every input, which is just your x value, has one output. Which is just another way to say y value. Okay, so what about B? Yep, that's still a function. Even though they all have the same output, as long as you have just one arrow coming out of each one, it's going to be a function. Every input has one output. All right. So any questions on either one of those? All right, so we'll do one more like this. We'll make sure one's still drawing. All right. Okay, so what if we had A, B, C, D, E, 1, 2, 3, 4, 5, and 6. Okay, let's say E went to 4, C went to 3, D went there, there, let's say A went to 1, B went to 2. Okay, so is this one a function?
No.
Nope, it's not a function. Whenever you can see your input having more than one arrow coming out of it, you automatically know it's not one. Okay, so it's not a function. Since the input D has more than one output. Uh-oh. Okay, clean that up. All right. So any questions on that one? All right. So just a little bit better than dealing with factoring. All right. Okay, so this is getting ready to shut off.